So today, let's talk about the atom. Or actually, let's talk about the picture of the atom and how that one simple image tells this incredible story about how science really works.
Oh yeah, you know this image. We all do, right? A tiny little nucleus with electrons just whirling around it like planets. This drawing, from a science book way back in 1918, just perfectly captures that whole idea. It's simple, it's elegant, and it is totally iconic.
Okay, but here's the twist. While this is the atom we all learned about in school, what if I told you it's less a photograph of reality and more of a really useful myth? What if the scientists who dreamed it up knew it was deeply, fundamentally flawed from the get-go?
So, to really get why, let's take a trip back to the classroom, okay? Back to the atom, you know. You know, the one that's all about clear facts and getting the right answer.
Remember high school science class? You'd get a question like this on a test, right? The atomicity of chlorine is diatomic. Argon is monoatomic. There's no debate. It's a fact. You memorize it, you spit it back out.
The symbol for iron, it's Fe, the molecular mass of water, 18 grams. The whole thing feels so solid, right? Like science, at this level, is just this big collection of unshakable truths. It feels certain, complete. But oh man, the story of how we actually got these truths is anything but. All right, so now let's peel back that nice, neat layer of certainty. Let's get into the messy, brilliant, and kind of revolutionary idea that gave us that planetary picture in the first place.
And believe me, things happened fast. In 1911, Ernest Rutherford discovers there's a nucleus in the atom. Just 2 years after that, this brilliant young physicist, Niels Bohr, drops a bombshell series of papers. By 1915, his model of the atom is the talk of the town. But, and this is a big but, to make it all work, Bohr had to break a huge rule of physics.
See, Bohr was up against a massive problem. According to all the physics they knew, an orbiting electron should be giving off energy all the time, losing speed, and just spiraling to its doom right into the nucleus, the so-called radiation catastrophe. So what did Bohr do? He made this incredibly radical move. He basically just declared it didn't happen. He said electrons live in these special stationary orbits, where, for some magical reason, the old rules just don't apply.
So why did anyone buy this crazy idea? This quote from 1913 pretty much says it all. The theory wasn't accepted because it made perfect logical sense. I mean, it didn't. It was accepted for one simple reason. It just worked. And not just worked. It worked brilliantly. It perfectly explained the light spectrum of hydrogen, something that had been a complete mystery for decades. The results were just too good to argue with.
Okay, so you've got a theory that on paper is physically impossible, but it gives you all the right answers. How in the world do you explain that to people? How do you sell such a strange, counterintuitive picture of reality?
Well, turns out it really helped that Bohr's theory landed right in the middle of a huge boom in popular science. The public was absolutely fascinated with all the new mind-bending physics that was coming out. They were hungry for books and articles that could make this stuff make sense. The challenge, though, was pretty obvious. The real theory was a bunch of complicated math. The answer? Find a simple, powerful analogy that everyone could get their head around. The planetary system. So Bohr's collaborators, guys like Hendrik Kramers and Helge Holst, they took on this mission. Their book in 1922 was a huge part of, as people have said, spreading the gospel of Bohr's atom and turning this weird mathematical idea into a picture everyone could understand. And this, my friends, is where our story takes a really interesting twist. Because while the public was falling head over heels for the simple, beautiful picture of the atom, the very people pushing it knew it had some serious, almost philosophical problems baked right in. And let's start with one of the weirdest problems, one that sounds almost ridiculous when you say it out loud. Do electrons have free will? No, seriously, I'm not kidding. This was a real conceptual puzzle the theory created. I mean, just look at this incredible quote from their book. They pointed out that when an electron jumps orbits, it's like it knows where it's going before it even leaves. It acts as if it's being guided by a future event. And, as they kind of dryly point out, that's a gift usually reserved for, thinking beings. It just totally defied any simple cause and effect explanation. So here's the really crucial point. Bohr's theory didn't actually explain what was going on inside the atom. And look, even Bohr himself admitted this. It was an amazing tool for connecting the facts, like energy levels and light spectra. But the why of it all was a total mystery.
These special orbits weren't explained, they were just described as isolated gifts from above. And believe me, this wasn't some secret whispered in back rooms. Critics were openly saying the model was built on arbitrary assumptions. And the guys who were promoting it, they admitted the real story was far from visualizable and had parts that were quite unintelligible. Bottom line, that simple planetary picture, it was a useful fiction, and everybody on the inside knew it. Okay, so if the model was so flawed and its creators knew it was flawed, why do we even care? Why did it become one of the most famous images in all of science?
Well, because this gets us to a really profound truth about how science actually works. Scientific models aren't meant to be perfect pictures of reality. They're more like maps. Think about a subway map, right? Geographically, it's a total mess. But it's unbelievably useful for getting you from point A to point B. It simplifies reality so you can actually use it. And that's exactly how Kramers and Holst saw Bohr's model. It wasn't the final destination, it was the keystone, that first essential stone you put in place so you can build the rest of the arch. It was an imperfect, simplified map, but it was absolutely essential for exploring the bizarre new world of quantum physics.
And that really leaves us with one last big thought. The story of the planetary atom is this powerful reminder that the simple, clean pictures we use to understand really complex things, whether it's the double helix for DNA or that expanding balloon for the universe, are often just useful myths. They're maps, not the territory. So it makes you wonder, right? What are the simple pictures shaping our understanding of the world today? What are our useful myths? And more importantly, what truths might they be hiding?